Hello. Today we are going to talk about how you can do machine learning with .NET. But first, please remember to subscribe to the channel, hit the notification bell, and invite more people to subscribe. You can also hit the thumbs up and share the videos in your social networks. Please remember to visit the links in the video description. Let's start. So, machine learning is a really extensive topic. There are a lot of algorithms. There is a lot of fields of study, and not everyone is expert on this field, right? So one of the things that the tools are trying to do is making it easier for most users to be able to do machine learning, right? So with what we are going to see, we can do some machine learning without having to have a really deep knowledge of the algorithms and of the internals of how machine learning works, right? This actually gives more people more power to do machine learning and create more cool applications, right? So here I have my Visual Studio, and the first thing that you need to do for what we are going to do is you need to go to Tools, Options, and you need to make sure that Enable ML.NET Model Builder is actually checked. You hit OK, and it should be able to work, right? The other thing is that if you see in here, I have a small project already created, and this is shows the basic console application in .NET Core running on .NET 5 actually. So we go and add new item, and we will choose machine learning in here. What we are going to do is we are going to classify animals based on images. We hit OK, and you see that in here we get a wizard requesting us to select the scenario, right? You can do text classification, value prediction, you can do image classification, recommendation, and object detection. The other things that you can do is you can choose limited scenarios for anomaly detection, forecasting, and clustering. This, as far as I know, you can only use the example datasets. For these ones in the limited scenarios, I think you are not able to use your own data. However, for the one that we are going to use, we can. We are going to select image classification. When you click over it, it will take you to a next screen where you will be able to choose if you want to train the model with your local CPU, with your local GPU, or with Azure. If you select local GPU, you need to check compatibility. It will show you if it is compatible. If you are missing some SDKs or frameworks, it will show you the links on how to install them, and then you will be able to click next when all of the checks are on green, right? Now, I won't use a local GPU because it seems I am getting an exception when I'm using it lately, and it seems I am getting the exception when I try to train with my GPU while I am using my video recording software. So I'll choose local CPU instead for now, right? I'll hit next step, and then it will request you to input or to select the folder where you have the images stored. The folder needs to have this structure. You need to have a main folder, which is the one you are going to select, and that folder needs to have subfolder a lot of subfolders where each of the subfolder is going to be a label or a category. For example, you will have one folder for dogs, one folder for cats, one folder for birds, one folder for fish, one folder for giraffe, one folder for koala, and the respective images on each of those folders that represent the actual animal or label in this case. So I am going to select the folder that I have already prepared in my machine. Images, and you see they have bear, cat, dog, fish, giraffe, and koala. Once you do that, you will be able to see some data preview. You see that it says total images 370, and it's showing 8 images of 63, of 62 in this case, etc., etc. And you see some images for each of the categories, right? So I hit next, and we click start training. Once I do that, the training process will start, and it will take a while, a couple of minutes, to be able to train. Now, the time that the training takes, it will depend on your computer power, your memory, your CPU, but it will also take or depend on the amount of images that you have in the model. Usually, the more images that you have, the longer that the training process will take, right? Depending on the amount of images, it can take from a couple of minutes up to hours. And I don't know if it will throw an exception after 10, 12, or 24 hours or something like that, or if it will allow you. Uh, I don't know how long it will be the max time, because you will probably also run out either of memory or disk space if you have a huge amount of images, right? For those scenarios where you have really, really big data sets, it is better to train with something like Azure in the cloud, right? Because that will have way more capacity than we usually have locally. Okay, now once the training process finishes, we will see a summary of the level of accuracy that we are getting with that trained model. The higher the level of accuracy means that the more chances we have of getting correct predictions when we input new images, when we try to recognize the correct label for new images that were not part of the initial, or that are not part of the trained model. Okay, ways to improve the accuracy, as far as I know from what people have told me, because I am not an expert on the area. Having a balanced data set, right? Uh, Basically, a similar amount of images for each of the categories that you are using. Have a really good difference on the photos, right? For example, a fish does not look anything like a cat nor as a giraffe, right? So it is a little bit easier to recognize those differences between those animals. uh, Having a very good quality on the images, right? That the actual thing that you are going to recognize, it's good. Also, something that I have seen is that you get better accuracy when the actual object that you are trying to recognize is as close as possible to the camera, right? When you have when the object you are trying to recognize is really, really far away from the depth, I mean, when it is really far from the camera, when it looks smaller, right, the lower accuracy that I have been getting. So that's something to consider, right? In some other scenarios, one of the things that you also want to do is have many different configurations for the same image, right? So for example, you have one image and the same, you copy that image, right? And you style it in different ways. You rotate it, you change the light, you change the background, right? Um, you can also change the scale, I believe, in some cases, and a lot of those will actually give you better accuracy. However, remember, you need to have similar amount of images, and probably if you do this about having multiple configurations for the same image, you may want to do the same for all of the images that you have in the dataset. Okay, so it should finish in a couple of minutes. Actually, it should finish. Uh, it should not take that long. Uh, may finish in a couple of, yeah, 1-2 minutes maybe, I guess. So once the process finishes, we will get the summary and we will be able to do some tests, right, with the images. To be able to test with an image with images that are not part of the dataset and see which is the actual score that we get and the actual label that we get with images that are not part of the trained model, and that will give us a small idea of how well that model will work when we start adding more images or when we start testing with other images, right, that are not part of the model. After that, we will be able to create a consumer application where when we're when we will be able to use the trained model in either a console application or a web API. So let's wait some time and we will see. Okay, it seems it is on the validation phase. Oh, it's phase training. Training. Accuracy 0.85, epoch 20. So yeah, it is getting like this wizard, as far as I know, I think it actually uses AutoML, and one of the things that does is actually get the best algorithm and the best number of iterations that will give you the best accuracy possible with the data you have, right? You see that in here, it is actually testing epoch 1, epoch 2, epoch 3, epoch, etc., etc., etc. I believe those are actually the number of iterations that it is testing your data with, right? And should finish in a second. Usually for machine learning training, one of the things that it's recommended to use many times is actually use your GPU, and it has been faster. At least in my machine, if I use the GPU, the training goes way faster than when using my CPU. However, as I stated before, um, I am getting an exception in Visual Studio when I try to train with my GPU if I am using my recording software at the same time. And currently I am actually recording the screen, and it's using the GPU, right? It's using the video card, so I guess it has something to do with that. Okay, so let's see. Epoch 20. Okay, so let's give it some more time so for it to finish, right? Um, that's what I was saying, that the more images you have, the more time that will take, right? And yeah, I'm using my CPU, which is actually slower than with my GPU. So that also is something to take in consideration. And I actually do not have Azure configured. Actually, I've never been able to use Model Builder with Azure. It always throws an exception when I try to do it. So I'm not sure what I am what I'm doing wrong for that. Um, Also, the machine learning in Azure has been changed a lot in the last year. So I remember that they changed like the workspaces. I believe they changed um, the the way you create workspaces, right, and the levels and all that. So I believe the SDKs for Model Builder um, were not compatible with that change. I need to test it again. I will probably record a video trying to do that, and we'll see how it goes. Okay, let's see which epoch it is at the moment. Yeah, it is still on 20. It may actually do more because, oh, it already finished. So you see that we are getting the summary. In this summary, we get we get the table, right? It, it tell us that the total experiment time was 741.56 seconds, right? And the total number of models explored was only one. The micro accuracy is 0.89 and the macro accuracy is 0.89. The duration and the iteration, right? Now we have it generates some code behind files, right? It installs some NuGet packages, right? And generates the code, right? And now it get this level of accuracy. Also, I am getting a better accuracy when I use my GPU. I am getting around 94% when using my GPU, and with my CPU I'm getting 89.35. That's still good for this test. Next step. Now well, it also tells you the model, DNN plus ResNet 5.0. If you want to test it, browse image, right? And this is a test image that we have in there. And it will tell us, okay, it has a 100% level of accuracy for fish and less than 1% for the other tags that we have in there. You click next step and you will see that in here you can create a web API or a console application. So I close this in a second and I'll open another solution that I have already configured with the web API because I actually changed something. So this is the other solution. It doesn't have a lot of changes. It actually only has one change. So this one, I use it to, I created a web API using the wizard, but I modified the web API because I wanted to be able to use images on the web. And the default web API assumes that your images are on the same computer where your API is hosted. Okay, so I already run the API and I'll open this with Postman. I am running this on the 44348 port, and this is the body that I need to have at the moment because I modified the model to allow for an image URL. I'll use this image, right? And I'll show you this. So first, the web API that you get, it has, of course, it has the config, right? You get the program.cs. Oh, the config also has, well, you have two more files, right? Which are the consumption.cs and the training.cs, right? And your zip file, which is actually the model. In your program.cs, it configures the prediction engine, right? And it tells that basically it's going to receive a model input and it's going to export a model output. And it will use this train model. Then it configures some endpoints, in this case only one. You access it through the predict route and it will invoke the predict handler. The predict handler basically gets the required service for the prediction pool, gets the body of the message of the HTTP request, it deserializes that into the model input data type, and then I am doing this. This is something that I added additionally. So I get the image from the image URL, so I get the image bytes. I create the file for the route, including the file name in my local drive where I want to store it. I write those bytes in the local drive where the API is hosted, and then to the input image source, I do set the local file, right? Once I do that, I will be able to click send. It will invoke the web API that I have hosted in there, and then we will get the prediction. It says that it predicted the image was actually of a fish, right? And here are some of the scores. Higher one is 99%, right? So that's actually a good accuracy. And this I don't think it was actually part of my model. Let's see with a tiger, which is actually not part of the model. So it recognizes it as a cat, right? However, see that the higher accuracy is of 59%. Yeah, it's this one, 0.59, right? So it predicted this was actually a cat, which is more or less true because tigers are of the cat's family, right? Or are related to cats. They have some similarities, right? However, the accuracy is really, really low, so you can assume it is not. Now, when that happens, first I'm actually using an image that it is not part of the categories that I trained my model with. So it will make sense to add that category, add tigers photos, right? And retrain the model with the updated dataset. Then you will get better predictions, right? Basically, each time you are getting low accuracy for an image, one of the things that you want to do is you want to include those images into the dataset where they actually make sense to be added, right? And retrain your model. The more images that you have in your dataset, the best, the better the accuracy that you will eventually get, right? So I hope this has been useful. Please let us know anything that you have been working with machine learning in .NET. Uh, I've seen a lot of cool examples. Recently, I actually saw someone which was doing that face face mask recognition using um, ML.NET, right? With something called WinML2, I believe. Uh, it was really, really cool example, right? There are other things that you can do. We have actually been doing some projects to identify like the ingredients on the food products, right? Like the tables for the ingredients tables, the nutrition facts tables, and all that, and those. Uh, using machine learning, and it's actually really, really good, right? Um, so let us know things that you may be working with. Thank you very much, and have a great day.